Well, today I am going to talk about Gaussian quadrature formula and which is used to do integration. So first of all, let us define integral which we want to evaluate. This is the integral from a to b f of x dx. This is the integral which we want to evaluate, right? So let us rewrite this integral in a new form. Means let us reframe this integral in a new form, that is -1 to +1 f of x dx, and this can be further if it can be approximated as wi f of xi, where I varies from 1 to n, right? And here this wi is known as the weight. So let us do. So that means first of all we need to transform the limit from a to b to the -1 to +1 and then express this in this form, right? So first of all we need to transform the integral from one form to the another form, and then we will talk about this part, right? So let us start with it. So for this, let us suppose that x and y are linearly dependent, so such that x is equal to p plus qy, which implies dx is equal to q dy. And let us assume that for x is equal to a, y is equal to -1, that's what we will assume, and for x is equal to b, that y is equal to +1, right? So if I do this, then how this integral can be rewritten as, it is a to b f of x dx, and it can be written as -1 to +1 and f of p plus qy, and it is dy q dy, right? We have just substituted their values here and we are getting this one, and due to this the limits changes from -1 to +1, and it can be written as q -1 to +1 f of p plus qy dy. Now our objectives to find out the value of p and q, that what should be the values of p and q. So to determine, let us proceed as follows. So means now our objective to obtain p and q. So as we know that at x is equal to a, y is equal to -1, which implies a is equal to p minus q, and for x is equal to b, y is equal to +1, so which implies b is equal to p plus q. Our objective is to find out the value of p and q in terms of a and b. So for that, let us add these two. So it is a plus b is equal to, this will cancel out, so it is 2p, and similarly if I write down, it is p minus q and b is equal to p plus q, and then take the difference, so then this will cancel out, and it is a minus b is equal to -2q, which implies q is equal to b minus a by 2, and from here we can write down that p is equal to a plus b by 2. So these are the values which I have evaluated. Means I have find out the value of p and q in terms of a and b, right? Now what do we do? Therefore x can be written as that x is equal to p plus qy, and it is a plus b upon 2 plus b minus a by 2y, right? And it is 1 by 2 a plus b minus a y. This is the value of x which we are getting now, and 1 by 2 can be taken outside here. So therefore now our integral, this integral, it can be written as q minus 1 to plus 1. It is f of p plus qy dy, and let us put their values. So it is b minus a by 2 integral minus 1 to plus 1. It is f of a plus b minus a whole upon 2 into dy, right? That's what we are getting here now. And let us call this whole of the function as 5 over y. So it is b minus a minus 1 to plus 1. It is 5y, right? And sometimes if we use dummy variable, rather than writing in some books, you can see that it can be written as minus 1 to 1 f of x also. It's basically we are using the idea of dummy variable. Whether I will write down 5x or 5y or g f of y, one and same thing, it doesn't matter, because function will again remains the same, right? So this is basically the idea of dummy variable, right? So in some books you can see here rather than 5y, you can somewhere you can see that it is fx, so it doesn't matter. And this can be written as and this is evaluated as in the form of a b minus a over 2, or note this, what it can be written as wi 5 by I, right? Where I varies from 1 to n, means this can be written in this form. Now this wi are called the weights, and n is the number of points through which fx pass. Right? So we will take here the example of we will take the example of n is equal to 2. We will take here example of n is equal to 2. So let us take now n is equal to 2. So therefore minus 1 to 1 f of x dx, its integral, it is wi or w1 5i1 plus w2 5i2, because we have taken n is equal to 2. So these are the 2 points which we are taking, right? So now to derive or to determine and sometimes it is written as phi x1 plus w2 phi x2, right? These both are representing one and same thing. So now to determine this, what we call w1, w2 and x1 and x2, or you can call this also as the y1 and y2, one and same thing, right? So to determine these 4 values, let us proceed as follows. And for this, for n is equal to 2, we will consider a cubic polynomial, because we have to find out the 4 values, right? So that's why we are using a cubic polynomial. So let us assume that the polynomial is this one, that fx is equal to a naught a1x plus a2x square plus a3x cube, then integral -1 to +1 f of x dx, it can be written as -1 to +1. It is a naught a1x plus a2x square plus a3x cube and its integral, right? And let us evaluate its integral. And when we evaluate its integral can become, it is a naught x plus a1x square by 2 plus a2x cube by 3 plus a3x4 by 4, and it's -1 to +1. That's we are getting here. These are the limits of it. Right? So it is -1 to +1, and let us put their values. So it is a naught 1 minus -1, right, plus a1 by 2 1 square minus -1 square plus a2 by 3 1 cube minus -1 cube, a3 by 4 1 4 minus -1 raised to power 4, means upper limit minus lower limit. So this value will become 2, this value will also become 2, and this will become 0, and this will become 0. So that's why I am getting, that is 2a naught plus 2a2 over 3, right? That's the value which we are getting from here. But what we have assumed, that -1 to +1 fx dx is equal to w1 phi x1, you can write down it as phi by 1 plus w2 phi by 2, or you can also write down it in this manner, f of x1 plus w2 f of x2, right? So this is basically the idea of dummy variable, so one and same thing. So now let us put its value here. So that means 2a naught plus 2a2 by 3, it must be equal to w1, it is a naught plus a1 x1 plus a2 x1 square a3 x1 cube plus w2 a naught a1 x2 plus a2 x2 square plus a2 x3 cube, right? That's what we are getting here. And let us separate out the terms. So a naught w1 plus w2 plus a1 w1 x1 w2 x2 plus a2 w1 x1 square w2 x2 square plus a3 w1 x1 cube and w2 x2 cube, right? Now let us compare both the sides now. So comparing both sides, here the term sitting with a naught is 2, so that means this whole of the term will be equal to 2. So that means we can write down that w1 plus w2 is equal to 2, and similarly w1 x1 plus w2 x2 is equal to 0. Let us call it as equation number 1, and w1 x1 square plus w2 x2 square is equal to 2 by 3, and w1 x1 cube plus w2 x2 cube, it is equal to 0. Let us rewrite down this equation. It can be written as w1 x1 is equal to minus w2 x2. Let us call it as equation number 2, it as equation number 3, and it as equation number 2, right? So let us do one thing now. Let us write down this as w1 x1 square, w2 x2 and x2 square is equal to 0, and let us put its value here. And if I put its value here, then what I am getting, it is w1 x1 square minus w1 x1 into x2 square is equal to 0. And w1 x1 can be taken outside. Inside it is x1 square minus x2 square is equal to 0. w1 x1 minus x2 and x1 plus x2. It's a simple formula, a square plus b square, which I am using here, and it's equal to 0. But x1 can never be equal to x2, so that means w1 x1 can never be 0, and x1 x2 is not equal to x2 because of this. So that means the term which is there, that means it should be equal to 0, and this means that x1 is equal to minus x2, right? So this is the one thing which we are getting, and let us call it as equation number 5. Now using this 5 in 2, when I put this value in equation number from here in equation number 2, then what will happen? This w1 x1 is equal to minus w2 minus x2. Sorry. X2 it is this one, which implies w1 x1 is equal to w2 x1, means w1 minus w2 x1 is equal to 0. So it means w1 minus w2 is equal to 0, which implies w1 is equal to w2, and let us call this as equation number 6. And using this in equation 1, using 6 in 1, so if I use this, then this w1 plus w2 is equal to 2, but w1 is equal to w2, so because of it, twice of w1 is equal to 2, which implies w1 is equal to 1. That means that w1 is equal to w2, and which is equal to 1, right? So this is the equation number 7. Now using this in equation number 3, using this value, using 7 in 3, and if I do this one, this is the equation number 3. So if I put these values here in this equation, so that means what we are getting, that w is 1 is equal to w2 and which is equal to 1. So if I put their values, so that means we are getting x1 square plus x2 square is equal to 2 upon 3, but x1 is equal to minus x2 or whatever you want to call. So that means twice of x1 square is equal to 2 by 3, which implies this 2 will cancel out with it. So x1 is equal to plus minus 1 by root 3, the value which we are getting. So therefore, if I sum up these results, so what we are getting, sorry, not sum up, first of all let us take x1 is equal to minus 1 by root 3, and then x2 will become plus 1 by root 3, and similarly if I take x1 as plus 1 over root 3, then x2 comes out to be minus 1 over root 3. So one and same thing. So right, so let us sum up these results. So if I sum up these results, then x1 is equal to minus x2, w1 is equal to w2 is equal to 1, and x1 is equal to minus 1 by root 3, and which comes out to be minus 0.5773, and x2 we are getting 1 by root 3, it is equal to 0.5773, the value which we are getting, right? So this is a way that we sum up all these results, right? That's all. So now we will do one thing to understand or to really appreciate this method. We will take an example, and in that example we will use the Gaussian Quadrature 2-point formula. Means we want to evaluate the integral, it is 2 to 4 dx using 2-point Gaussian Quadrature formula, right? So let us have a look at it, that how this can be done with the help of this formula which we have derived here. Because in the derivation we have to put all these values, and then means the values which we have evaluated, we have to put these values here, right? We know that what is the value of f of x1 and what are the values of f of x2 and what are the values of w1 and w2, and using all these values here we can evaluate this integral using this formula, right? So let us go to our problem which we want to discuss now. This is a very simple and interesting problem which we are going to discuss. So here in this problem, that a is equal to 2, b is equal to 4, and q is equal to b minus a upon 2, means 4 minus 2 by 2 is equal to 1, and the value of x is equal to b plus a or a plus b plus b minus a by 2 into y. So let us put their values. It is 2 plus 4 minus 2 upon 2, and here y is multiplied here, so it is 6 plus 2y upon 2, or this is the value of this, and 2 will cancel out, so it is 3 plus y. So that means x is this, x is equal to 3 plus y, and dx is equal to dy, which we can write down it here. So now let us transform the integral. So integral I, it is 2 to 4 f of x dx. It can be written as integral minus 1 to plus 1 f of 3 plus y dy, or q, right? And the value of q will be 1. So it is f of 3 plus y dy integral minus 1 to plus 1, which we are getting. So let us put their values, because this is our f of x, right? So if I put their values here, means in place of x I am putting 3 plus y here, then what we are getting, it is integral minus 1 to plus 1, it is 3 plus y whole square plus 3 plus y and into dy, right? And let us simplify it. It is 9 plus y square plus 6y, 3 plus y minus 1 to plus 1, it is dy, and this after simplification will gives us minus 1 to plus 1, it is y square plus 7y plus 12 dy. So now I is equal to integral minus 1 to 1 y square plus 7y plus 12 dy, and it is equal to w1 phi 1 y1, w2 phi 2 phi by 2, not phi 1 but phi yeah, it is phi by 2, right? So, or in place of phi by 1 you can also replace it by f of x1 and w2 f of x2. So let us take n is equal to 2. So if I take n is equal to 2, so for such a case w1 is equal to w2 and it is equal to 1, and y1 it is minus 0.57735, or you can also call it as x1. This is similarly, and this is plus 0.57735, or you can also call it as x2, whatever you want to call. So now let us try to find out phi y1. So phi y1 is equal to y1 square plus 7y1 plus 12, and it is equal to minus 0.57735 whole square plus 7 into minus 0.57735 plus 12, and this after simplification it will become 8.291883, and similarly we can calculate value of phi by 2, or sometimes it can also be written as x1 to and fx1 and fx2, whatever you want to call. So it is y2 square plus 7y2 plus 12, it is equal to plus 0.57735 whole square plus 7 into plus 0.57735 plus 12, and this after simplification it will become 16.374783. Now our objective is to find out the integral, and the integral is minus 1 to 1 f of x dx, it is equal to w of phi by 1 plus w2 phi by 2, and its value is 1, its value is also 1, so it is 1 into 8.291883 plus 1 into 16.374783, and when I sum up all these, means both the results, then the value which we are getting, it is 24.666666, right? This is the value which we are getting. This is the result. Now let us compare this result, and basically this result is equivalent to 224 x square plus x dx. But if I actually calculate its value, means if I evaluate this integral x square plus x dx, it is 2 to 4, and it is x cube by 3 plus x square by 2 dx. And sorry, not integral is not substituted here, and it's integral from 2 to 4. Then what is it? It comes out to be nearly equal to 34 point, sorry, its value comes out to be 24.666666 and so on, 66. It keep on repeating. So that means this result is much more closer to this result, because this 66 is repeating itself, right? So that means Gaussian quadrature formula is also very good formula to find out the integral. Now let us generalize this formula, because here we have taken only 2 points, n is equal to 2, but if we will take n is equal to 3 or n is equal to 4 or n is equal to 5, then how things will change. So here we have taken a cubic polynomial. Here we will take a polynomial of 5th order, and here we will take a 7th order, and here we will take a 9th order polynomial. So if we will take large value of n, then how things will change. So let us make a table for that. So here let us write down the value of n, then degree of polynomial. I will talk about it here. Degree of polynomial, then the points which we are taking, and here we will take the value of weights, right? So let us have a look at it, that how things will change. So first of all, let us take degree will be 2, n will be 2. Then we will take a polynomial of degree 3, as we have taken in the earlier example. The points which we are taking, it is x1 and x2, and x1 will be minus 0.57735, and its value x2 will be minus x1, and the value of weight will be r1 is equal, sorry, not r1 but w1 is equal to w2, and both are equal to 1. That's what we will take it here. And then for the next, means when we will take n is equal to higher value, n is equal to 3, then 5th order polynomial we will take, and here x1 is equal to minus 0.774596, and here x2 will be 0 and x3 will be equal to minus x1, and the weights w1 is equal to 0.555555, and w2 is equal to 0.888888, and w3 is equal to w1. Then let us take its 4, and here it is 7th order polynomial we will take, and the value of x1 which we are getting, which we are taking 0.8611363, then x2 is equal to 0.3399810, and x3 is equal to minus x2, and x4 is equal to minus x1, and the weights which we are getting w1, w2, w3 and w4, and w1 is equal to 0.3478548, and here it is 0.652141515, and W3 is equal to W2 and it is equal to W1. So you can also try the same problem by taking the large value of n, and these are the points and the weights which we will use in the Gaussian quadrature formula, right? So that's all for today's lecture, and in the next lecture I will talk about the Romberg integration. That is also very interesting problem, right? So thanks for watching.